100 years ago from today, on November of 1915, when I hope it was not raining, Albert Einstein first presented to the world his general theory of relativity. A theory so powerful that it single-handedly transformed the way we look at the universe. However, even after 100 years, we still haven't been able to prove the fundamental assumption and prediction of Einstein's theory, which is the existence of gravitational waves, or as Einstein would call it, the ripples on the fabric of space and time. My PhD thesis has a modest ambition. I developed search algorithms that can detect the first gravitational waves, and I'm going to use these gravitational waves to find the most energetic event in the universe, which is the collision between two black holes. As you can see on the image on right, which is taken from the Hubble Space Telescope, there are two galaxies which are on their way to merge with each other. In fact, our own galaxy, the Milky Way, is going to merge in this exact fashion with the neighboring galaxy Andromeda. The part that I'm interested is in the black holes at the center of these each galaxies are going to come very close, they're going to collide and form a bigger black hole. And during this collision, they are going to release energy, so much so in just 1 millisecond that our sun cannot release that energy in its entire 10 billion years of lifetime. And all of that energy is released as gravitational waves. To understand what happens when two black holes collide, I solve Einstein equation on one of the world's fastest supercomputers to understand the gravitational waves emitted. The image you see on the left upper right is the snapshot from our simulation. I use this information from my simulation, and then I look for the signature of black hole collisions from the largest and arguably the most ambitious scientific instrument built on United States soil. The instrument is called LIGO, and it is a gravitational wave detector. The image you see on lower left is the aerial view of one of the LIGO detectors. Black hole collisions we are going to see very soon, and as soon as we start seeing them, we will be able to probe parts of the universe which no telescope has seen before. And this can help us answer the fundamental question regarding the growth and evolution of our universe. Furthermore, the detection of black holes using gravitational wave is going to be an ultimate tribute to Albert Einstein and his contributions on the 100th year celebration of relativity. Thank you.